Hi. Usually I do this during my seventh hour, so there's usually a lot of time for students who are viewing these to write and fill in because I'm doing it at the same time. But I forgot to hit record, so we're doing this after I've written in all the things. So if I go a little fast or you feel like you need me to stop, simply pause the video and write down what you need to write down, and then and then hit restart and you'll be able to keep up. So we just finished Unit 3 when we talked about the inside of the atom. Now we're going to talk about how the atom connects with other things a little bit. Basically, we're going to be talking about matter. So today's lesson is about matter and the different ways that we can classify it. Matter is simply defined as anything that has mass and takes up space. You may have also heard the definition as anything that has mass and volume, mean the same thing. Examples of matter are coffee, that's a liquid, or a solution, a liquid or a solution. Coffee cup, which is solid. Coffee table, also a solid. The air around us, that's a gas. Examples of things that are not actually matter. Fire is not matter. Energy is not matter. Light is not matter. Heat is not matter. Space by itself is not matter. So things that are not matter are things that, technically speaking, don't really have mass and they don't really take up space. So those are ways that we can identify what matter is and what matter isn't. So the way that we classify matter is in two different things. Matter can either be a mixture or it can be a pure substance. So when you're looking at a substance or some matter, you can ask yourself the question, can I separate this relatively easily? And if I can, it's a mixture. If I cannot, it's a pure substance. And we say things like separated relatively easily, like, can I pour it through a filter and separate it that way? Or can I just evaporate out the liquid and separate it that way? Or could I just simply pick it out with my fingers to separate it? Those are examples of mixtures. And when you were in elementary school and middle school, you might have heard of homogeneous and heterogeneous mixtures. And those are things that are important, but we're not going to cover them in this class because we don't really spend a lot of time with them. But we're just going to call mixtures. And examples of mixtures would be like if I took a bag of M&Ms and a bag of Skittles and mixed them together. I don't know why anybody would do that. If you went to the beach and you grabbed a bucket of sand, that would be a mixture. A salad is a mixture. Now, if it's not something that can be easily separated, we call it a pure substance. And those things are things that we find on the periodic table or are in combination with things that we find on the periodic table. So pure substance, we ask ourselves, because there's two types of pure substances that we kind of deal with. We ask ourselves, is it made up of one type of atom on the periodic table? And if it is made up of one type of atom on the periodic table, we would call it an element. So examples of elements would be neon, which is gas, mercury, which is a liquid at room temperature, and iron, which is a solid at room temperature. Those are examples of elements. An example of a compound, which is something that's made up of more than one type of atom on the periodic table, would be things like sodium chloride or table salt, NaCl, water, H2O, carbon dioxide, CO2. So the difference in the examples is that neon is just one element, but sodium chloride are two elements and they are bonded together. And we'll learn more about bonding in the future. But for now, that's the difference between an element and a compound, which are types of pure substances. The other thing that we discussed in class today was how to make good observations of matter. Basically, observations are using our senses to collect some data, and it's really easy to do, but how we describe the data that we collect that way is kind of important, and I've listed some things below. So we generally use our four of our five senses when we are making observations. We don't ever taste anything in the lab. That's a really bad idea. But we use our sight, and we use touch, and we use feeling, or we use sound, um, you know, those, and smell. We use those things. So one of the ways that we take good observations is we talk about things that are by their color. So here I have a bottle of hand sanitizer. I happen to have it on my desk, and the way you might describe the hand sanitizer is some people would call it clear, and that's true. But in terms of a color, we would usually say it's colorless, or we might describe the color as being light red or dark blue. We also would try to describe the substance's state of matter. So again, this hand sanitizer is closer to liquid than it's not. So we would say it's a liquid. The other states of matter are solid and gas. And then another way that we can describe matter is with it's how it smells, or its odor that it gives off. Sometimes a substance won't give off an odor, so we will simply say it's odorless. And sometimes we'll say that a substance has a strong odor or a pungent odor. And depending on the substance, you might be able to identify the type of odor. Like you might say, oh, this smells like an orange, even if it's not. Another way that we identify matter is texture. Some things we can simply touch and be able to identify the texture, smooth or slippery or rough. Some things that are not really good ideas for us to touch, but we can still identify them as looking smooth or looking rough or dry. A way that a person might describe like table salt would be that it looks grainy or granular. A way that a person might describe flour, like for cooking, would be, or baking rather, would be looks like a powdery substance. And then getting back to clear. So coming back to this particular hand sanitizer, the fact that I can see through it, we could say that it's clear, but we could also call it transparent. So sometimes we might say things are transparent or they are not transparent. And those are great ways to observe matter. Another thing we talked about today is physical and chemical changes. And again, I think this is probably a review of some of the things that you have learned about in your past academic experience. But a physical change is something where a change has occurred to the substance itself, but it has not made a new substance. So examples of that would be cutting or tearing an object, a change in state of matter like melting or freezing, evaporating or condensing, dissolving or crystallizing. Those are all changes that don't change the substance, so we call those physical changes. A chemical change is a change where we end up with a new substance as a result of after the change has occurred. So things like chemical reactions, or burning something, or rusting, or oxidizing. Those rusting and oxidizing are examples of reacting with oxygen in the air. And those are changes that once they've happened, you can't undo those changes easily. I mean, we can with a chemical reaction in many cases, but we can't just undo them by simply like rubbing off the rust or something like that. It's still going to be rust. And then how do we know that a chemical change has occurred? There's a bunch of ways that we can identify that and look for, and things we can look for. One of the things we can look for is the formation of a solid when there was not one before. So there's an opportunity later on in the year where we are going to mix things together, and we mix things together that weren't solid at all, and all of a sudden a solid is there. That's a really good indication that a chemical change has occurred. An obvious color change is also a really good indication that a chemical change has occurred. And by obvious color change, I mean something drastically happened. Like when you think about paper, right? If it's a white piece of paper and you burn it, the result is like a black char or a lighter colored ash, right? So that's an obvious color change. Formation of bubbles is an indication that gas is being produced, and that's also a great indication that a chemical change is happening. A change in temperature, which is different than like letting something cool down. So like if I take my coffee and I put it, and I pour myself a cup and I put it on the counter and I walk away and I get busy and I come back to it 20 minutes later and it's cold, that's not a chemical change. What I mean is like when you take those like those hot packs and you break them or whatever, or you bend the bend the disc inside of them and you hold on to them and they get warm without having done anything to them, that's the type of change in temperature I'm talking about. And then the last identification that a chemical change has occurred is something called formation of light, which is basically if a reaction is occurring and you can see light appearing, that means it's a chemical change. So and not all of those things have to be present for a chemical change to occur. It could just be one of them, or it could be a couple of them. So that kind of sums up the lesson for today. And if you have any questions, please reach out to your teacher and we'll talk about it. Have a great day.